Okay, thank you. Thank you, Andrea. So the idea of this presentation is to present to you the outcomes of use case 2, which is about dynamic spectrum allocation. So the main objective of this use case was to incorporate the spectrum as a resource that can be traded in the 5GZORRO DLT-based market. We considered here that, first of all, 5G opens the door to new actors beyond traditional MNOs. So they want radio resources, they want spectrum resources, and maybe it's complex to them to access to the traditional market. Then we have the operators. The operators, they want to maximize revenues regarding their spectrum, which is scarce and also expensive. And then we have the regulators that they want to facilitate this trading. They want to adopt digital transformation. As commented by Swaib, in the team we have MCA and a regulator, and so we are aligned in this view. So considering all of this, the idea is that 5GZORRO implements automated and secure transactive spectrum sharing. So the main business scenario that we have considered is an area where we have industry verticals, where they need this spectrum or radio resources to enable Industry 4.0 use cases. These are the stakeholders that we have considered. I have already commented them, but we have also here the radio resource provider that is the one that provides the hardware, let's say. So one of our main innovations here is the definition of the spec token. So the idea is to digitalize the spectrum resource. And for that, this spec token, it's a way of digitally representing the spectrum resource, consider the band, the frequency, the area, the validity time. We implemented this through non-fungible tokens, NFTs, which are stored in the marketplace. And the idea is that the holder of these spec tokens is able to trade or to use this spectrum. So this way, in order to participate in the market, the spectrum providers, they need to get their licenses, their real licenses accepted by the regulator. This triggers the generation of a primitive spec token that represents this license. And then the provider is able to go to the market and trade. Logically, the provider will not offer the entire spectrum in the market. So the idea is that it can segment these resources in a way that he provides different offers that are not overlapping, consider the frequency, the area, or the validity time. And when these offers are offered in the market, the consumers are now able to order it through the platform. So after a trading occurs, we generate a smart contract between the consumer and the provider, and also a derivative spec token, which is derived from the primitive spec token, and it represents this segment of the spectrum. And now the idea is that the consumer is able to use it for deploying slices. And how we are doing this, so as commented by Giacomo, we also implemented in the platform a zero-touch automated way of deploying run slices in a way to facilitate this procedure to the consumers. So the consumer just needs to select the orders, spectrum and the radio order, to specify some parameters related to the service, like the payment ID, the IMSIs that are allowed to use the service, the DNN. And then we deploy the slice using the orchestrators and the controls that are integrated in the platform. So we even ensure that the radio devices that are being used in the platform are ready to use this spectrum, or even if needed, we're able to configure them. So the last step here is, okay, we have deployed the slice. Now we need to monitor that its operation follows the SLA that was associated to the offer. So here the idea is that we define metrics that can be monitored. We define rules that are able to detect these SLA breaches. For instance, in this use case, we consider the location of the radio nodes, interference levels, the transmission power as a way of checking that the operation of the spectrum is as was defined in the spec token. Also, we can consider the time to deploy it as a way of ensuring that consumer is not getting monopolizing all the resources in the platform to avoid that competitors are able to participate. And yeah, the idea is that 5GZORRO monitors SLAs and is able also to solve conflicts. So it's able to compensate consumers in case of a SLA breach, also to terminate slices if it determines that we have a harmful slice there, or even we are able to redeem spec tokens if the SLA breach is very severe or serious in the system. So now it's time for the demo. The idea is that we have prepared three different videos showcasing different operations related to this use case too. So the first one is related to spectrum management. You will see all the part related to spectrum certificate generation, the generation of the primitive spec token, the part of generating the spectrum offer, including the SLA, and ordering this spectrum offer that triggers the generation of the derivative spec token. Then the part of slice management, the offer, the order, the deployment, and also the testing. And finally, the part of SLA monitoring, where we will emulate an SLA breach based on location, not moving the real hardware. It's emulated to avoid going to Barcelona with the radio. And also, we will show how we terminate the spectrum and the slice. Also, let me remark that this testbed was done in Barcelona with real 5G hardware and UEs, radio, and core. So it's time for the videos. Okay, it's starting. Okay. So we will start with the certificate request part. So this is operator B, the spectrum provider. This is related to the real license that it has. And this request is sent to the regulator that will accept it. And after it gets accepted, this is shown in now the operator will have the license and will be able to use the spectrum for trading. Now here you can see, so this is the smart contract lifecycle manager. It's able to connect to the Corda vault and to show the primitive spec token and the NFTs that has been generated. So here you can see that the issuer is the regulator and the holder is the operator B. Now it's time to create the offers. First of all, we will create an SLA template. We will onboard the SLA template and create an SLA. Later, we will go again on these SLAs. So very fast, you can see that they are putting the metrics, the rules to monitor the breaches. This is SLA that has been generated. And you can see there the different service commitments. Okay, now the idea is that the spectrum provider will generate this spectrum resource that is a small piece, a segment of the license. You can see here the different frequencies, the band, etc. This is generated. And so it's related to the license. So we have a way of associating the offer to the license that enables its generation. And you can see here different parameters related to this offer, to this resource. And now the operator is able to generate the offer related to this resource. You can see here again the different values. It selects a validity time, a price, and it associates this offer to the SLA that we have created before. Okay, now we have created the offer, and the offer is available in the marketplace, so the consumer will be able to use it. Okay, that will be the next part of the video. Okay, now we see the consumer. The consumer gets to the marketplace and see the offer and orders it. So after ordering it, it becomes active in the marketplace, and we will see that we have generated the derivative spec token. In a moment, we go to the API of the consumer, and we can see the spec token here that is associated to the primitive spec token, and also we can see the NFT that here we will have the issuer, the spectrum provider, and the holder is the consumer. Okay, so in the next video, we incorporate now the operator A, that is the one that provides the radio resources, and also as a way of deploying the slice. So these are the different steps that we will see in the video. So we start with the offer creation for the slice. So this is operator A now. Okay, so this is so one thing to mention is that this is a configurable slice. That means that the radio devices are not configured, so they are prepared to be used in a specific band, and we use the configuration of the spectrum to configure these radios to our orchestrators. So you will see that in the order that we have through in the configurable type. So we create this offer, linking it with a validity time and a price, and this offer will appear in the marketplace. Okay. So now it's the time to create it. And the first created. Okay. And the video showing that all the operators have access to this offer. So now operator C does an intent-based search. So the idea is that it can go to the market and write, okay, one spectrum and a slice in band 77 in Barcelona. So this way the search filters the different orders. Now also it's able to compare the trust score of the different providers to find the better order according to the reputation in the platform. As I commented, so it's a configurable one in band 77. And yeah, the consumer will select it. And will place the order. Okay, now again, the order becomes active in the marketplace. So now is the time to deploy the slice. So this is the next video. So operator C goes to the marketplace and goes to ICCM and will deploy this slice. As I commented, it just needs to provide through this file some parameters of the service, the deployment ID, the IMSIs, and the DNN. And then it will select the order. So since this is a configurable slice, it needs also to select a spectrum. So not only the radio part, so it's forced to select the spectrum and the radio and to deploy. So now we have a new transaction, and you will see here that, yeah. So you already see this in the use case 1 video, but it's a slice deployment. So with all the different steps that are needed for that. So now we have sent the orchestration request to operator A, the slice provider. And you can see here the orchestrator. It gets the parameters from the spectrum to configure everything. It polls the orchestrator. And you can see here that, yeah, the slice is being instantiated. Okay, now something interesting that we will go later on this, that we created an SLA event that links the transaction with the SLA to be monitored. So later we can monitor the SLA of this slice. So the deployment was successful, and you can see here the transaction ID that is linked to this slice instance. And this is the testing. So basically here we have an Amarisoft-based radio that was configured using the platform to use the radio configuration of the spectrum, also to be connected to the core that was deployed. You can see here that they are connected. In the right side, we have the user that starts the radio and connects to the Amarisoft. You can see here that it's connected now. It gets an IP. And now we will show that, okay, it's connected to the signal levels, that is connected to 5G radio, to the deployment ID 00103, if I'm not wrong. And now it starts an hyper. That is just to show you that we are monitoring the radio with a custom Prometheus exporter. You can see here the throughput, for instance, or the quality of the signal. Okay. Go to the next one. So in this final one, we will demonstrate the part of SLA monitoring. Okay, so the idea is to showcase the part of monitoring and breach detection, and then the different corrections that we can do. So as you remember, so when we created the order, the spectrum order, we associated to a SLA. So these were the parameters. We considered the location of the GNB, the transmission power, the software interference, and the time to deploy. Here we will consider for the demo only the location. So these are the values and the rules, the different thresholds that you can see here. We linked this with the slice instance. So everything is linked in the platform. You can see here the metrics that are being exposed through the Prometheus exporter. So this is the interference. These are the location, the longitude, and the latitude. This is sent to the Prometheus server, and this Prometheus server, the system is able to, the platform is able to trigger the metrics from it. So these metrics are sent to the data lake particularly. So you can see here the transaction ID, the different metrics, the values. And these metrics also are sent to the SLA monitoring. This is the next step. And the SLA monitoring, according to the SLA, monitor these metrics, consider the different rules and thresholds that have been defined, and in case of a violation, they say that they send an event to the data lake according to this violation. You can see this here. So we have the transaction ID, we have the SLA ID, and we have the type of violation that has occurred. In this case, is related to the location. And this is just a Grafana showing how the radio was moving, and okay, when it's out of the range of the of the area, we get this SLA breach. So the final step here is that, okay, we detect this through the portal, so we have a warning that an SLA breach has occurred. Operator B, the spectrum provider, gets this and is able to see, okay, I need to now to check this violation. It can go to the smart control lexicon manager and see that this violation has occurred. This is just to showcase that this is in the system. And then the idea is that it will go and terminate the spectrum order. So you can see here, it goes to the order. And this was stated in the SLA that because if this breach occurs, it will go and terminate the spectrum order. And you will see here that it has been cancelled in the system, and also the derivative spec token will be deleted. So it's cancelled through the marketplace, and now you can see that the NFT is not there, so it has been deleted. So now this consumer is now not able to use this spec token again. And this is the part of the slice provider. Very similar, it gets a notification, and now because of what was stated in the SLA, is able to go to the marketplace and cancel the slice and terminate it. So you will see this in the different steps. So now we terminate the slice, and after some seconds, you will see that it has been canceled in the system. So first in the marketplace and later in the ICCM. So it's terminated now. And in a few seconds, it gets terminated. Succeeded, now it's terminated. And that's all from my side. So thank you.